A constant internal body temperature is crucial for the needs of a warm-blooded animal's metabolism. The normal oral temperature of a human is 37 degrees centigrade. Core body temperature, regulated by the hypothalamic thermoregulatory center, is normally maintained within a range of 36.5 to 37.5 degrees centigrade. The hypothalamus serves as the body's thermostat. Similar to a home thermostat, the hypothalamus sets the normal body temperature within a range. In fever, the hypothalamic set point is temporarily reset at an elevated temperature in response to pyretic substances. There is no impairment of the thermoregulatory mechanism. During fever, the hypothalamus senses that normal temperature is below the new set point and initiates the cold responses mechanism to increase temperature to reach the new set point level. Conversely, an increased body temperature resulting from dysfunction of the body temperature center, impairment of thermogenesis or heat loss mechanism is not fever. Such condition is termed hyperthermia, that occur when body produces or absorbs more heat than it dissipates. Exogenous pyrogens like gram-negative bacteria, gram-positive bacteria, virus, antigen-antibody complexes cannot directly pass across the blood-brain barrier to act upon on the hypothalamic thermoregulatory center. So they can activate certain cells of the human body to produce endogenous pyrogens. There are three cells mainly that produce endogenous pyrogens: mononuclear macrophages, including blood monocytes and tissue macrophages, tumor cells, lymphocytes, neuroglial cells, and mesangial cells. When bacteria or breakdown products of bacteria are present in the tissues or in the blood, they are phagocytized by these killer cells, and these cells digest the bacterial products and then released cytokines, a diverse group of peptide signaling molecules like interleukin-1, tumor necrotic factor, interferon, and interleukin-6. Numerous studies have demonstrated that endogenous pyrogen is not the terminal substances to raise the set point of the thermoregulatory center. Endogenous pyrogens may induce the production of series of central mediators that raise the hypothalamic set point. These central mediators include the prostaglandin E, sodium and calcium ratio changes in the brain, and cyclic AMP level in the cerebrospinal fluid, corticotrophin releasing hormone, and nitrogen oxide produced by the nitric oxide synthase. Numerous studies have shown that the pre-optic area of the anterior hypothalamus is the body's thermoregulatory center. Fever alters pre-optic area of the anterior hypothalamus neuronal activity, upregulating the hypothalamic thermostat set point. In short, pyrogenic activators induce synthesis and release of endogenous pyrogens from a variety of cells. Peripheral endogenous pyrogens are transported into the brain through the bloodstream. Endogenous pyrogens stimulate cells of the pre-optic area of the hypothalamus to produce central mediators, which in turn act upon neurons of the thermoregulatory center to reset the set point. In this stage, the hypothalamus senses that the pre-fever body temperature is too cold, so it initiates the cold response mechanism like shivering and vasoconstriction to elevate the body temperature. In febrile stage, heat production balances the heat loss to maintain the temperature at the elevated level. At this point, the patient feels neither cold nor hot. When pyrogenic activators are removed, the hypothalamic set point is restored to normal and therefore initiate heat response mechanism to cool down the body. The skin is warm and flushed. Sweating occurs to increase heat loss. The basal metabolic rate increases 13% for each 1 degree centigrade elevation in body temperature. Nutrients are consumed rapidly during fever. Fever increases the excitability of the central nervous system. Irritability, delirium, and hallucination may occur when the temperature reaches 40 to 41 degrees centigrade. Headache, a common symptom accompanying fever. During fever, every 1 degree centigrade rise in temperature leads to an 18 beats per minute increase in pulse rate. Elevated blood temperature leads to hyperventilation, which increases oxygen supply for body tissues. The function of the digestive system is often suppressed during fever. Fever increases the anti-infection capacity of the body. Elevated body temperature kills many microorganisms. Patients suffering from fever often needs adequate fluid and simple carbohydrates to support the hypermetabolic state and prevent tissue breakdown that is characteristics of fever. Meanwhile, sponge baths of cool water used with caution to reduce body temperature. Antipyretic drugs such as aspirin and cortisone are used to protect extreme elevations in body temperature.